Well, welcome to today's Connected Sessions here at Learn Academy. My name is Brian Banville, and I'm the Career Services Manager here. So I support everyone in finding those first initial jobs and every subsequent job after it, after our students go through our academy and enter into the workforce. Um, just a few reminders about our connected sessions. Our connected sessions are opportunities that we have to share some of mostly our alumni stories and experts that come from our alumni network to continue to share our education out into the community and to support those who are interested in other different technical areas. As a part of that, we like to bring our classroom setting as much into these connected sessions as possible. And in our classroom setting, we like to say that we create a brave space. We do this so that people feel encouraged to ask questions, to participate, and to actively learn. In addition to that, we also like to keep a very safe space. And so as a result, we do have a zero tolerance policy for anyone on any of these types of events who's using divisive language or behavior. Because it does not match well with our ideals and the community that we're trying to build. And so if that does happen, by the off chance, we will remove that individual from the meeting. So, and that is to continue to support all of the great things that our alumni are bringing to the table. And so today, I'm super excited to welcome Caitlin Johnson, very affectionately known to the Learn team as CJ, who will be sharing a little bit about her experience going from health consultant to data engineer I want to say, CJ, I was going to say like in less than a year, but it's probably more like less than 6 months. So CJ has a really great way that she kind of got into data engineering and is currently a data engineer who works remotely, lives throughout Mexico, which is pretty awesome. But today she'll be sharing a little bit about data engineering 101. And with that, CJ, I welcome you to today's connected session, and I will hand it off to you.
Awesome. Hello, everyone. Yeah, as Brian said, my name is Caitlin or CJ. You know, whatever nickname works for you, go for it. And I'm going to talk about data engineering. I'm not going to go too deep in the weeds because there are a multitude of different flavors of data engineering, and that would extend this talk from 1 hour to a week for me. So I'm not going to bore everyone to death. I'm just going to touch upon the high level concepts and then leave some time at the end for questions for those of you that are interested or, you know, want to talk more about some of the topics that I touched upon. So with that said, here's the agenda that I have in mind for today. Just go over myself quickly, talk about what a data engineer is. It's changed over the past few decades from what I've read. I've only experienced the present day data engineering since I've been in the field for only 2 years at this point. But I definitely got some insight into what a data engineer used to be in the past because of certain organizations not really moving quickly in that aspect. And then I'm just going to touch upon, you know, basic data engineering concepts and how people can leverage their Learn experience or really, you know, bootcamp or self-learning experience. I'm going to mostly focus on Learn experience because that is the bootcamp that I went to. So maybe that's something that you can keep in mind if you're, you know, considering Learn as your bootcamp. So let's go ahead. So I graduated from Learn Academy in October, November, something like that, 2018. I was part of the Delta class. It was an amazing experience, and I cannot stop thinking about how it was such a great time and whatnot. Amazing people, amazing instructors, amazing leadership, and, you know, just all around an amazing experience. But as you might be familiar with, Learn Academy is a full stack web development bootcamp. So during this time, I leveraged this experience as a way to figure out what aspect of programming I really wanted to get into. I didn't know if I wanted to be, a full stack developer, a backend, UX, different aspects. So it was at this time when I stepped into an evening course seminar of some sort hosted by a not-for-profit organization about data science. And that's when I started to realize, okay, this is the aspect of programming that I really want to get to. Don't know if I want to do data science stuff because that's a lot of math, and I can do math, but that's just not what I want to do for my job. So I, spent some time trying to find that, sweet spot between data science and programming. And that's how I found out about data engineering. So I'll go into exactly what data engineering is later on, but that's just how I found my job. So about me, graduated from Georgia Tech in 2012 with biomedical engineering. I do have 2 computer science classes under my belt from that experience. So that has helped some, but I wouldn't necessarily say that those were it's not like you can't get to where I am today if you don't have that, if that makes sense. I worked in the healthcare industry, started out as a glorified customer support job, went into healthcare consulting for a few years, which involved traveling every single week and just making presentations and whatnot. Realized 3 years into that job that was definitely not something I wanted to do. So that's when I took the leap and decided to enroll in Learn Academy in summer of 2018 with the Delta program. And my passions are data, Latin American cultures. Throughout the past few years, I've traveled to within Mexico, some countries in South America, Bolivia, Colombia, and whatnot. So that's actually a huge part of why I am in Mexico for the time being. And obviously, I love tacos. I probably love them too much, to be honest. And so here is my path. After I graduated from Learn, I got my internship at Zito. It's a startup just a couple of blocks away from Learn Academy in downtown San Diego. They're in the advertising space, more like Google AdWords, but on a startup level. So I did my internship there. It was a great experience. They put me on the data team within Zito with the intention to move me to an area within Zito that I wanted to move into. But I just happened to love being on the data team so much that I just stayed there. So after my graduation, I was fortunate to get a full-time job offer from Zito, and I was there until June of 2019, end of June of 2019. That was when my life priorities changed and I needed a remote job. So I was blessed to have an opportunity to work with a company called Privia Health. It's a health tech company in a way based out of Arlington, Virginia, and that was fully remote. So that's when I also decided to move to Mexico, specifically Mexico City. And now I just started a new job last month, July. And it's with a company based out of Atlanta, Georgia, which is actually where I'm from, called Park Mobile. You may be familiar with that app. I think they have a couple of parking spots within San Diego, but you might be familiar with it, but it's a fast-growing contact-free app for parking that's getting more and more attention around the US. So that's my timeline for how I got to be a data engineer, and this is my current situation today. That is literally a picture of where I used to work on the beach in Akumal. It's just north of Tulum, where I am currently situated. and it's been a fun experience. It looks a lot better than it actually was. My battery ran out of time after like 2 hours of doing data engineering stuff. So it looks a lot better than it really is in the picture. But anyway, so currently a data engineer for Park Mobile. As I mentioned before, it's a contactless, contact-free mobile parking app that is kind of evolving into some sort of parking platform where people can use the app itself as parking lot operators to figure out, okay, you know, what spots are not getting, or what lots are not getting a lot of clients. And apologies if I seem to stumble around words. It's still an industry that I'm learning and trying to better understand. Since I used to be in healthcare, it's been a little bit of a shift for me. I'm on a data team of, I want to say 3 in-house FTEs for data engineering and 3 contractor FTEs for data engineers as well. So it's half and half, in-house versus contractors. 1 data modeler, so she's the one that is, you know, she decides how the table is going to look, what data types, what flavor of data types, if you will. We've got a product manager who kind of, you know, tells us what to do, what the priorities are and whatnot. We've got a project manager, which is different from our product manager in that she helps us coordinate meetings with people on other teams, because she literally told me word for word, engineers are really bad at coordinating meetings and scheduling stuff. So that is her primary role, is to schedule meetings for us, which is awesome. And then we've got a director who's got his, he's got his feet in a couple of different places. One of them is data engineering. So he pops in from time to time to see how things are going and making sure we're on track with everything. I'm also engineering lead for our team. I'm not technically an engineering lead, but I just happen to have the highest level of seniority on the team. So they're just, you know, plugging me into those engineering lead meetings until we do find a lead, or maybe that ends up being me. But that's kind of up in the air right now. Remote work. So company is fully remote because of COVID. Before COVID, it was a very engaging, very engaged open office kind of company. So when they do open the office again, it's going to be permanently optional for everyone. So it's been kind of an interesting shift. I joined the company just as they're starting to get used to it. So it's been interesting to watch how people adapt to it. And it's an agile framework. So 2 weeks, 2 week sprints, but it's very, very relaxed. I get tickets, you know, assignments during these weeks, but they don't have deadlines. So it's more of just an organizational thing. So, and please let me know if you have any questions. Obviously I'll have questions at the end, but please interrupt me if you do have any. I'm more than happy to, you know, talk about that. So let's go ahead and go into what a data engineer is. So you might have heard the term lately. It's become a very, very popular industry. A lot of people talk about data scientists, but a lot of people, usually the same people, forget that we need data engineers in order for data scientists to do their jobs. You know, you have to get data from one place to another. And I believe statistics say that you need at least 2 or 3 data engineers per data scientist. So given that data scientist is like the hot, you know, buzzword for the industry, you can double that, and that's how important data engineers are today. So in short, it's a growing field. It's made my job search a lot easier. So I'm happy about that. So data engineer, people, when they think of data engineers, they think of database administrators or extract, transform, load developers, you know, moving data from one place to another. And that's not necessarily what a data engineer is. A data engineer is actually a software engineer that just makes products that are data sets, or they are products that move data from one place to another. And I'll go into more details about this, but definitely not your typical database administrator these days. It's kind of evolved into a software engineer that is that has a primary role of getting data from one place to another in a usable and meaningful fashion. So I'm not going to go into too much detail, but this is basically what I was touching upon earlier, is that data engineers used to their primary responsibilities usually lived within a database itself. So you start up, a website, and you want people inserting user information or, product information that helps your website run. You would probably just have one database for that does everything for that website. And the data engineers back in the day, they used to be primarily responsible for just that one database, because back in the day, we didn't really have the concepts of capturing all of the data that we do today. But if you fast forward to today, data engineers are heavily responsible for multiple databases that are on completely separate platforms. For example, in my job today, I have to be responsible for data within Snowflake. Snowflake is a cloud data platform that is it has completely changed the data world today. It's an amazing company. I highly recommend checking them out if you're not familiar with that term. So I'm primarily responsible for data within Snowflake. I'm also responsible for data within a Microsoft SQL server that's actually on premise. It's on company property. It's a physical server that we actually own. I'm also responsible for data in AWS. And the list just keeps going on. So that is a huge difference between data engineers historically and data engineers today. And another huge aspect that changes us, or that separates us from data engineers in the past, is the volume of data. So a lot of the times you'll hear the term big data. Big data usually refers to data sets that are larger than 1 terabyte, or a couple of gigabytes or whatnot. It really depends on the industry, but it's just massive sizes of data sets. So that's another huge distinctive factor that separates us today from data engineers in the past. So data engineers in the past, they used to work with these graphical user interface applications. You might be familiar with it, but the most popular one I would say is Microsoft SSIS. And essentially, this does not involve any programming whatsoever. You pick whatever action you want to take on a certain data set. And you might be able to say, like, I want to execute the SQL statement on this data set and do this at some hour every single day or whatever. So that is what they used to work in today. They also heavily worked in relational databases. So, tables within a database that relate to one another somehow. That's a relational database in very, very, very high level terms. And as I mentioned before, they were only responsible for getting data in and out of one database. So their scope was super small, and they didn't really do any programming, and it was primarily relational databases. However, today, you mentioned big data. So present day data engineers, a lot of what they work on is Python, Scala. So they are actually developing scripts in a programming language, not SQL, but an actual programming language, usually Python. Python, I would say, is the most popular one. but Scala is becoming more and more popular, especially for actual big data engineers. So they leverage these programming tools to move data from one place to another. And sometimes that involves SQL statements. So, you know, they execute some sort of SQL statement within their programming language to do what they want it to do. They also leverage relational databases. So as I mentioned before, relational databases usually consist of data that somehow relate to one another. These relational databases are extremely useful for operational purposes. So if somebody needs to find all of the sales that were made in one day for a certain product, they can easily use this. But as we find over time, relational databases are not super useful for analytics. Analytics, they usually execute the same kind of SQL statements or same kind of queries, but they want the data quickly, like the faster the better. So they started using NoSQL databases. NoSQL does not necessarily mean not SQL. It just means you can leverage other, you can leverage SQL, but also other data types. So I'll go into that in a little bit more detail, but NoSQL databases are great for analytics. They are great for big data because of the way they store data. So data engineers have had to transition their knowledge base from relational to also include NoSQL databases, which are set up completely different and used completely different from relational. So that's been a learning curve for a lot of us. And as I mentioned before, big data engineers, they deal with increased volume and speed of in which data has been generated. As you can see here, 43 trillion gigabytes of data will be created by 2020, which is an increase of 300 times from 2005. And if we, talk about data engineering concepts from the 1990s or, even earlier than 2005, the size of data sets are significantly smaller than that. So that should be able to help you paint a picture of how much data engineering has grown over time. And then, as I mentioned before, the size of data that we have is what distinguishes us from the earlier time data engineers. So let's go into what my major priorities as a data engineer. So as I mentioned before, I am a software engineer, but I primarily work with data concepts. So give me a second. So data modeling, cleaning data, data analysis, and building and maintaining data pipelines are my major priorities for my current job today. And you might be wondering what a data pipeline is. This is essentially a set of processes that get data from one place to another in a way that you want it to. So this can involve getting data from an API in the internet, for instance, into your database. But let's say that I'm gonna turn off my notifications real quick. I forgot to let my coworkers know that I'm doing this call, so my apologies. But so you can get data from an API in the internet to your local database. But that data that's sitting in the database is raw data, might be in a format that is not really usable or readable for the end users, which might be analytics, it might be your boss, it might be the CEO of the company. They might not want to read something that's in a JSON format. So the next part of this pipeline is to also clean the data, which is this bottom part here. We need to make sure that this data is actually meaningful and useful. And this also involves making sure that they only see the data that they care about. So if you pull a data set from an API, let's say Twitter, for instance, and the tweet contains a lot of information like the hashtags, the content, who posted it, the date, geography, all that kind of stuff. CEOs probably don't care about who posted it. They probably care about the number of times that a certain word about their company was posted over a period of time. So you need to make sure that when you talk with your stakeholders, you are also getting what they care about the data. So that way you can limit the data size to what's actually needed. And this makes your job a lot easier and quicker. Another aspect of this is data modeling. So this ties in with what I was just saying before. It's like, okay, what data does the consumer want? What specificity of data do they want? Do they want to see seconds in a timestamp, or do they want to see just the hour or the date? So those kind of questions, that when you ask the end user what data they want, you should also ask what level of detail do you want, and based on that, that will help you shape the database or the table that you're creating for this end user. And then data analysis is also another aspect of this. A lot of people that get into data engineering also actually come from data analytics departments and whatnot because of their ability to do data analysis. Sometimes, we'll get a call from the CEO saying, hey, this we're not seeing as many transactions at this hour on this day as we were expecting. Can you dig into this a little bit? And, during your investigation, you need to start pulling in your data analysis skills and say, what am I looking for here at this time for the CEO? And these are just a few of the major priorities, but in my current day, these are my major priorities. Some other ones might involve making dashboards for the end users. You might be familiar with applications called Tableau or Looker, or even BI, business intelligence. Some of these products you might actually be involved with as well. During my first job at Zito, I was kind of like a jack of all trades. So I had to build pipelines, I had to clean data, I had to model data, I had to talk with end users and figure out exactly what they wanted to see in their dashboards. But in my second job at Privia Health, I did not touch dashboards at all. I was only responsible for building data pipelines and getting data in their raw format to the database, and then other data engineers would massage the data and make sure that it's in a format that's usable for their end users. So depending on your role as a data engineer, you might be involved in a whole lot more things, or you might be primarily responsible for just one thing. So that's something that you should keep in mind when you look for jobs, is what is the scope of a data engineer, and is this something that you want to do? And then this is also representative of what I do on a day-to-day basis. 1/3 of it is programming. I primarily work in Python, sometimes Go. And that's actually been an interesting mix for me, because I didn't know Go before getting this job. So it's been interesting. I also do a third of my day is also in SQL and data analysis. A lot of the times, especially today, like a lot of times I get questions like, hey, we're not getting the data that we're expected to get during these statements. Can you take a look at that? And then I have to go into Snowflake or whatever database that this data lives and start doing some sort of data analysis. And then another third is design meetings. And this may honestly, this will vary, depending on what your position is, but primarily because I'm considered as the lead on the data team, I'm in a handful of meetings for, new projects that are coming down the pipeline, or just bi-weekly meetings that we have with other engineering leads. I would say that the most important aspect, or most challenging aspect of being a data engineer, is staying up to date with the new tools and concepts that come out in the industry. As I mentioned before, you can see like how drastically different data engineering is today as it was 15 years ago versus 30 years ago. So there's a lot for us to keep up with on a daily basis. And it's important for us to, A, understand what these new tools are, or new concepts, or a different style of data ingestion and whatnot. And B, and this is the hardest part, is figuring out if it's actually needed for your organization. So it might be cool to, start learning some new concept or even a new database, and it's the biggest buzzword in the data engineering field on that day. And it's really hard to be able to say, to step aside and say, this is cool, but we don't need it. It's not really gonna be, it's not gonna get our team on a whole new level if we start using this. So I would say that's one of the hardest aspects of being a data engineer is A, knowing what's out there, and B, knowing whether it's actually useful for the company that you work for. So I mentioned a lot of these tech stacks already. So programming languages is probably the most important, one of the top two most important aspects of being a data engineer is knowing a programming language and doing it well. And also understanding how to use SQL. So within relational databases primarily. But I'm starting to see a lot of job postings talk about NoSQL databases, especially if you're looking to work for companies like any of the FANG companies, Facebook, whatnot. I interviewed for Google recently, and their biggest, I guess, priority was knowing how to use NoSQL databases. Cloud technologies, people are moving to the cloud. I think this goes for pretty much any programming field within the industry right now, but definitely for data engineers. Everything is basically in the cloud. The company that I work for, Park Mobile, they just moved to AWS last March, this March of this year. And we're still in the process of moving to Snowflake. So not all companies have done it. The one that I used to work at, they were still in Microsoft SQL servers, on-premise Microsoft SQL servers. So there's still an opportunity to learn what it means to transition into the cloud if that's your interest. And then development strategies. So this, whatever you learn in self-taught or bootcamp or computer science classes, functional programming versus object-oriented programming. Those are useful in data engineering. I find data engineering to primarily focus on procedural programming. So it's like, this executes, then this executes, then this executes. Not a lot of object-oriented programming. It's more of a very step-by-step kind of programming style. Lots of big data engineering tools, Apache, anything Apache really is a really cool concept for data engineering. And then the general data engineering tools like SSIS, those are slowly going away. They're not as big as they used to be in the data engineering world because of what I used to say, or what I said earlier. And then your typical general technologies, GitHub, Git, Docker, those are extremely important. I'm seeing Docker get mentioned a lot more in data engineering job positions. So you might be wondering, okay, so you're saying you're a software engineer that works with data, but what's actually the difference? Like, why did they give you a title of data engineer instead of, software engineer? So again, we primarily work with data sets. I don't make a client-facing application. I don't make websites or anything like that. I just make products that move data sets from one place to another. Or I make data sets that are actually meaningful for the client so that anybody in analytics can make a dashboard off the table and know exactly what's in that table. Mentioned before methodology. We don't really program in the typical feedback loop cycle that software engineers usually program. They build a product, they release it to end users. End users say, hey, this is cool, or hey, this is not cool. And the feedback comes back to the software engineers, and they iterate and iterate and iterate. Whereas data engineers generally, and this is generally, but not always the case, but when somebody comes to us and they say, hey, we want a dashboard that shows this data. That's it. We just take that, we make a pipeline if we need to, or we make a dashboard that shows that data. And then that's pretty much the end of that project. Maybe they might say, oh, I don't like these colors, or I don't know if a bar graph makes sense here. I would rather see this kind of other graph. Then we might take that back and tweak it as needed. But it's not nearly as of a, it's not as much of a feedback loop as you would get in software engineering. Let's see what else. Tools. I would say the tools are very similar. We use Git, we use programming language tools, we use text editor or IDEs, depending on your preference of programming. We primarily use a lot of databases, whereas software engineers might use something like API tools like Postman or something like that. So that I would say those really specific modules are where data engineers and software engineers differ. Let's see. Okay, this is gonna be a little bit boring, so I'll probably just skim through this, but I do think it's important for people who are interested in data engineering to know about this. So as I mentioned before, the concept of getting data from point A to point B is primarily what data engineers do. And this part of the process is called ETL, or extract, transform, load. And I'll add some caveats to that, but this is when you hear the term ETL, you can immediately think data engineers. That's what we do. We get data from one aspect to another, and we also transform it to make it look prettier or more intuitive for the end users. And then we load it into a database or dashboard or something like that. So extract, it can be, I primarily extract data from one database in a completely different platform to our database within Snowflake. But a lot of times people extract data from APIs, or even something as simple as CSV files that we've just historically had data within Excel sheets, and we now need to load the data into a database. You gotta get started somewhere. So CSV files is a common one to extract data from. Once you do that, then, and this is where things get a little convoluted, but a lot of times, if it's a small data set, then you can actually transform that data in the process of extracting it and loading it into a database. But as we're starting to see with these big data concepts, doing a transform of something as simple as changing a date format from a timestamp to a date may take a lot more resource than we actually really want it to for an entire data set. So what I've started seeing people do is they do extract, load, and then transform. So keep that in mind with big data engineering concepts. That's generally the path that we go down. But in the traditional aspect of data engineering, we do extract, transform, and load. So transform can be something as simple as, let's say, you're grabbing data for users in your website. But when you store data in your JSON format, instead of saying this person is male, you would store that data as M. But if you show that data set to an end user who has, a table of end users for the website, they might not find that as meaningful as something as male, female, non-binary, etc. So part of the transformation can involve actually putting in words instead of just abbreviations, so that the data is actually meaningful for your end users. And then the last aspect of this is load. So this generally, when we talk about load, it means loading data into an actual target table. So usually you'll load the data in a staging table or a staging area, and then convert or pull pieces of the data into different tables. Hopefully, some people get pipelines where they only need to transfer or extract data into one table. And those pipelines are super easy, and I love it when I get those. But most of the time, it involves loading data into a staging table and then figuring out exactly what pieces of the data go into which table, if that makes sense. Not going to go into too much detail, but I mentioned before, relational databases where you have tables that relate to each other somehow. Sometimes you might have different pockets of relational tables within a relational database. And I'll talk about that later. That's a completely different style of relational database. But the takeaway here is that within a relational database, tables generally relate to each other one way or another. And this is because this is done in a way so that data takes up less storage within the database. And it's even with the concept of Nosql and the companies like Google, Facebook, Netflix, making NoSQL databases much more commonly used today. Relational databases are still by far the most commonly used databases in the tech industry. So it's important to understand what makes a relational database what it is. So as I mentioned before, relational databases usually have data tables that relate to each other. But as I mentioned, they might have pockets of tables that or clusters of tables that only relate to each other. And that's where you get into the Snowflake scheme. This is what I would say the majority, if not all, data engineers work with. And generally it's not really any different than dealing with the star schema. It's just, you just have a little bit more data to deal with. But you might commonly hear those two terms used within the data engineering world. And jumping into NoSQL. So as I mentioned, the term NoSQL can be confusing because NoSQL, people might invert that as in NoSQL is usual. When in reality, it's actually not only SQL. So for instance, you might have a NoSQL database that brings in data in a SQL fashion, but it can also bring in data in a variant form. So it can bring in data in JSON or some sort of array or some sort of non-SQL database or data type. So that's what NoSQL really means. And as I mentioned before, this is growing in popularity. It's actually a great database to start off with if you are doing a side project for a website. They're super quick, they're super lightweight, and they're super easy to set up. But generally, once you get beyond the concept of a pilot project or a proof of concept MVP product, that's when you really need to think about what relational database to transition to. Oh, and as I mentioned below, companies are not restricted to one type of database or another. First company I worked with, we used a NoSQL database and 3 different relational databases. The company that I currently work at, we only use relational databases. So it's not necessarily something that all companies need to do. It's more of a what databases work best for my current situation. Becoming a data engineer. So if you are going through a bootcamp, if you are thinking about going to learn as a bootcamp, there are many ways that you can get into data engineering from the skills that you obtain during bootcamp. So generally data engineering roles are mid-level in terms of programming experience. They expect a lot of data engineers to have about 2 or 3 years of programming experience. Obviously, they have exceptions, otherwise I wouldn't have gotten into this industry. You can find these entry-level jobs as internships. They have a lot of internships out there for data engineering. but there's also different ways to get into data engineering after your boot camp. You can continue your learning experience by taking some sort of online program or something like that. Excuse me. Sorry, my girlfriend's cooking dinner. So it's not something that's commonly jumped into after boot camp, but it's not impossible. So transferable skills from Bootcamp or Learn Academy, pair mod programming is a huge one. And this goes for really any programming position after bootcamp, not just data engineering, but software engineering, analytics, whatever. Anytime that you need help with some sort of programming concept, you have to get engaged into a pair programming setting where you are, especially during these times during COVID when everything is 100% remote, you need to call up a colleague and say, hey, you know, I'm trying to figure out this problem. Do you mind if I share my screen and go through this code? But in order to effectively communicate with your colleague and help them understand what problem you're encountering, you have to be able to understand exactly what to say when you're going through your code or you're trying to, you know, troubleshoot an issue. So pair and mob programming is a huge, huge aspect of you know, just being a programmer, mostly in communication styles. Unit tests are so huge, and I have been burned a couple of times by not using unit tests within my code. I know we all hate it, but they are important. Learning how to do 5-minute TED Talks. This again plays into the whole communication style. Like, you need to explain your new product to the CEO. They are going to only have 5 minutes to listen to you, and then they need to work on something else. So learning how to effectively communicate what you've done is incredibly important, especially if it's a dashboard that has, you know, 10 different graphs on there. You need to concise it into a 5-minute talk. Capstone. So Learn Academy has a capstone at the end of it, where you work on a small team of people, and you know, you work on some certain tasks depending on how the team divvies up the work. This goes for any you know, job you get after Learn Academy, but knowing how to play with other team members is really important as a data engineer, especially since data is kind of like the foundation of all you know, types of programming. You need data to be able to do whatever you're doing. So as a data engineer, I have to interact a lot with API engineers, with backend engineers, front-end engineers, and whatnot. So learning how to interact and communicate with different types of players is incredibly important as a data engineer. And of course, anything relating to database Postgres, SQL Server, MySQL, whatnot, incredibly important for data engineering, especially when you get into the interviewing portion of it. And then last is APIs. So during my capstone project, we worked with a lot of APIs to pull data into our website. And that is a huge, important component of being a data engineer, is knowing how to get data from an external source into your internal database. And as I mentioned before, this is not just, you know, these are not exclusive skills for data engineers. These are extremely important for pretty much any job that you get afterwards. And then, you know, a lot of people are like, well, you know, I went to boot camp for full stack development, but I don't know what other aspects of my previous jobs are applicable for being a data engineer. Actually, being a data engineer heavily relies on skills that are not programming, heavily relies on how to effectively communicate to your stakeholders. So that can come from client relations or customer service jobs. Doing data analysis to quickly troubleshoot. This can be something simple as knowing how to clean up data within an Excel spreadsheet. Industry knowledge. This is key. As a data engineer, you can only be so effective at your job if you know the data that you're working with. This is actually my challenge with my current job right now. I've never been in the parking industry before. So when I look at a table, I'm like, this data, I understand what it looks like, but I don't necessarily know how it plays with other tables within the database. So it's a learning process for me. But in my previous job and for a healthcare company, I was able to hit the ground running because I knew healthcare data. I knew what a certain term meant, how it plays with another table within the database and whatnot. And then project management, this goes for pretty much any job. You need to be effective at your task. You need to know, what is an appropriate amount of time to spend on a certain task before raising your hand and saying, you know what, I'm stuck here, can you help out? So knowing how to do project management is very important as well. So my recommendation is to learn Python. Python, if you're interested in being a data engineer, Python is the most popular programming language and it is super easy to learn. There are tons of resources that you can use to pick up on Python. Express yourself as a data enthusiast. You say, I've worked in data, as a data analyst or business analyst. I've always been interested in data. Now I just want to learn how to program modules that use this data, so you can easily play that in your interviewing process. Become more comfortable with SQL. So there's HackerRank, there's LeetCode, there's a ton of resources out there, even books from 20 years ago that are still applicable for today because SQL has not changed at all. Like over the past 20 years, select statements are the same. You can obtain a certification. I've seen and heard from people that getting a AWS or Google Cloud certification is a huge boost in the job search. I don't personally have one. My experience in Snowflake helps a lot. It is a cloud application though, so I highly recommend getting experience in some sort of cloud application. And then side projects, you need to know how to do data engineering and one easy way to do that is doing simple cloud or side projects. And to have those in some sort of Git repository, whether it's GitHub or Bitbucket or GitLab, something that you can actually share with your recruiter and say, yeah, I know data engineering, here are the projects that I've done and whatnot. So those are really key aspects or just things to have under your belt before you start recruiting or interviewing for data engineering jobs. Tons of resources, Reddit's data engineering subreddit. I'm a huge lurker of that subreddit. I learn a lot of new concepts there. Medium articles, they usually outline side projects that you can do and whatnot. There's a couple of newsletters out there that you can sign up for and books and whatnot. Tons of resources out there that you can leverage to become a data engineer. And that is it. I've only got a few minutes. I did not mean to go on that long. As I mentioned before, data engineering is something that I can go on and on and on and talk about. So I do want to give you all a few minutes to ask me questions about data engineering. But if we don't get to you, or if you think of additional questions that you have, these are ways that you can contact me, my cell phone number, Instagram, email, and LinkedIn. Feel free to reach out to me on any of those platforms, and I'm more than happy to talk with you about data engineering. And
cool.
that is it.
Awesome. Yeah, thanks, CJ. We do have a question. Ben, I think I just unmute. Oop.
Okay, does that work?
Yep, yeah, you're good.
Hey, so thanks for the talk. That was awesome, very informative. I don't know, I haven't seen you there, but shout outs to the data engineering in San Diego. They, all the buzzwords you're talking about, Snowflake and Azure and pipeline, BI, all that stuff. Really great resource. I've been learning a lot. So my question to you is, I've been working basically in a data engineering team. However, I haven't been touching SQL. I do a lot of extracting and scraping data from sources and do a lot of AWS. I've been building like notification pipeline stuff and a lot of interesting stuff, but I haven't been touching SQL, which makes me feel like if my trajectory where I want to go is data engineer, I feel like that might be the only tool that I'm not practicing at my day job. I was wondering what your thoughts are about that, and like again, this is my first year working. I'm really loving the ecosystem of data engineering, and I just figured that would be an interesting to hear what you would say from being also a Learn graduate.
Yeah, so data engineers, when they use SQL, it's usually to investigate data. So it's basic, like select statements, understanding how to do joins, wheres, filters like where statements, whatnot. Where it starts going into data analytics is when you do a lot of subqueries and you're pulling data from those subqueries into another subquery and whatnot. So do not stress too much about getting into those extremely complicated SQL statements. Highly recommend this is what I did for my previous interview, which, got me on the level of comfort for interviewing for this job. But I basically just went to HackerRank and leak code and just practice beginner and intermediate level SQL queries. Just knowing how to limit data, how to maybe some window functions like adding row numbers would be important, but I wouldn't stress too much about it. I was interviewed for this job, and it was basically a simple select statement doing a group function, which is really, really basic level for what I do. So I highly recommend just checking out LeetCode, HackerRank, just, run through the beginner level SQL statements, get comfortable with those, then move up to medium. You can go into the hard levels if you want to, but those are more of data analytics rather than data engineering. Does that help?
And in addition, I have one more is what are your thoughts about, because like you even commented, data engineering typically is more of a mid to senior level role. And the one thing also with my position that I've learned a lot and I've performed a lot in is search engine. Do you have any thoughts about that, where that typically stands in the companies that you've worked in, like Elasticsearch and making data searchable?
Yeah, that's actually a part of data engineering that's growing a lot. I personally haven't touched upon that aspect, but if you browse data engineering, I'm starting to see a lot of Elastic references, a lot of making data searchable, which obviously would be super useful for any company that you're working with. Cool. Any other questions or comments? Really good questions so far. Thank you for that.
CJ, it looks like we have a lot of thank yous, which I always take as because you were so thorough, which is awesome. Well, CJ, thank you so much for today. If anyone has additional questions, as CJ said, please do not hesitate to contact her. You can see her email there on the screen. So if you haven't already taken a screen capture, please feel free to do so. And as always, CJ, it is always a pleasure with us. So thank you all so much and have an awesome rest of your day.
Talk to you all later. Thank you. Thank you.